In this video, we are going to determine the equation of an exponential function. When determining this equation, there are three different variables that you might have to determine. The a value will indicate whether there was a reflection around the x-axis. The b value indicates if this graph will be increasing or decreasing, and the q value once again shows us the horizontal asymptote. Example 1. Determine the equation of the given function in the form y is equal to b to the power of x plus q. So here it is indicated that we should only determine a b and q value. If we go and have a look at the sketch, you will see that the horizontal asymptote is indicated, and this lies at y is equal to minus 3. So we know that the q value is minus 3. To determine the b value, you will realize that there's another coordinate given on this graph with an x and a y value that we can substitute. So if I now substitute y with 6 and x with minus 2, I can solve b. Now I will add the 3 on the left hand side, and then I need to solve b by getting rid of the minus 2 in the exponent. For this, you now have many options. One, for example, can be to raise both sides to the power of minus a half, because once you do that, on the right you will be left with b to the power of 1. Simplifying the left hand side, we will have 3 to the power of 2 to the power of minus a half, and multiplying the exponents will leave you with 3 to the power of minus 1. This means that b is equal to a third. Or you could have chosen to rewrite the negative exponent in the denominator. Now, to get rid of the square, you can add a square root on each side of the equation. So 1 over b will be equal to 3, and that is why b will be equal to a third. So the final equation will be y is equal to a third to the power of x minus 3. If you now realize that you need some revision on solving exponential equations, you can follow the link in the description to that video. Example 2. Determine the equation of the given function in the form a times b to the power of x plus q. So this time we need to determine all three variables' values. Again, I'm going to start off with my horizontal asymptote, which is given as y is equal to 18, and substitute that into the equation. Further, if you look at the sketch, you will see that the graph is below the horizontal asymptote, which means there was a reflection around the x-axis. So you can just keep in mind that the a value should be negative. Now we still need to determine two variables, and that is why we are given two extra coordinates. When you are given the y-intercept, you will see that the b value automatically falls away. Let's have a look at why I say that. If we substitute the y value with 16 and the x value with 0, you would know that anything to the power of 0 becomes 1. This means that b to the power of 0 becomes 1, and then we can solve a. In this case, a will then be minus 2. In this equation, we now only need to determine the b value, and we still have one coordinate left that we can substitute. In y's place, I will substitute 0, and in the place of x, I can substitute 2. We can solve b by moving the term 2 times b squared to the left-hand side, and then dividing both sides by 2. If I now take the square root on both sides, I will end with b equal to 3. So the final equation is y is equal to minus 2 times 3 to the power of x plus 18.